Okay, here's our third example of uniform annual payment, also known as annuity. And in this example, we are going to find the annuity given the future value. So remember, as we're looking at all of these, we're looking to find an economic equivalence of one cash flow, in this case the future value. What is its economic equivalence if it was a uniform annual payment over 15 years? So we're finding the annuity given the future. And both of these cash flow streams have the same economic equivalence, or are economically equivalent. So we want to accumulate $15,000 to put a new roof on vacation home in 15 years. So we're going to be pulling the money out, so that's money up coming to us at the end of year 15 so that we can pay cash for the roof repair. To have this amount, you will put in annual payments into a savings account that earns 8% per year. So we're given 8% per year. Again, there's no talk of compounding, so we're going to make the assumption that there is no compounding through the year. That 8% per year is the nominal interest rate and the effective interest rate, since there is no compounding. How much must each payment be? And we're talking about putting in annual payments, so we know the frequency of our payment is annual as well. So we know our 8% per year is our correct I. And we're trying to find our annuity. So again, we have the setup here that this by definition is, or derivation, again you can see that in the book, is what an annuity looks like. No cash flow the end of period 0, the exact same cash flow the end of every period 1 through 15, or whatever time period we're looking at, consecutive. So we have a future value of $15,000, we have an interest rate of 8%, and we have a period of 15 years. So we want to find A. We have a future value. We want to find the annuity given the future at an 8% interest rate over 15 years. So again, this is the functional notation that the engineeringandtrainingexam.com videos talk about, that we're going to use. The formulas for these functional notations are in the front cover of the inside of your book for both the single payment, which we talked about in prior class sessions, as well as for these annuities. So our future value we know is $15,000, and we get this factor, this find the annuity given the future at 8% over 15 years, from the compound interest tables. We know that we go to the table that the interest rate is 8%, we go to the row that n equals 15, and then we go across until we find the column that says we're trying to find the annuity given the future, and you'll find that factor is 0.0368. You could plug the interest rate and number of periods into the formula that, again, you can find in the front cover of the inside of your book, and it would give you this exact same number. So the tables are just there for convenience. So 15,000 times our factor of 0.0368 tells us that our annuity is $552. So if we put in $552 the end of every year, years 1 through 15, then we'll have $15,000 to take out at the end of year 15 when the interest is at 8%. So again, we think about this from an economic equivalence perspective. We are economically indifferent to $15,000 at the end of year 15, or 15 payments, annual payments of $552 given an 8% interest rate. Those are economically equivalent cash flows. And that takes care of the example problems for annuity, uniform annual payment. And what I'd like you to do is look at this last slide here, and hopefully you've printed these out. They're on PolyLearn. And I'd like you to bring the solution to this, so bring the present value of this cash flow stream to class. And so my hint here is it's a two-step process, right? We have an annuity. Oops, sorry, didn't mean to move that. We have an annuity right here, and then we'll bring that to a single payment. Then we take that single payment back to 0, right? So I just basically gave you the 2 steps to do it. So hopefully it'll work out, and you can check your answer in class. Thank you.